Alright, we are going to work on the second part of the notes, which is applying Pythagorean's theorem to a few different things. So our first thing here is we have a special triangle. If I look, these two sides are equal, which means these angles are equal, which makes these angles have to be 45. So angles A and B are 45 degrees. So often we call this a 45, 45, 90 triangle. It says find h in the simplest radical form. So if I use Pythagorean's theorem, which again a squared plus b squared equals c squared, so I have x squared plus x squared equals h squared. Well, that's the same as 2x squared equals h squared. And I'm trying to solve for h, so I have to square root both sides. I don't know the square root of 2 because it's irrational, but I know that x squared is x. So x square root of 2 is h. So what that tells us is anytime I have a right triangle, and these are both 45, so I have an isosceles right, these are equal. Whatever this is, this could be written as x square root of 2. So if this is 10, this would be 10, and this would be written 10. I'm sorry, you can't see it. Oops. If this was 10 and this was 10, this would be written 10 square root of 2 is our answer. All right. So then just a couple little things. Pythagorean's theorem. The purpose of Pythagorean's theorem is on any right triangle to find a missing side. So one, we have to know that it is a right triangle, and it can find any side. Often kids learn that it's just to find the hypotenuse, but it's really any side. And our equation is a squared plus b squared equals c squared. I'm not going to go too much into it because you've done this last year. The only thing I really want to make sure we remember is that c is always the side from the hypotenuse. It's the longest as well. Or not the side from the, it is a hypotenuse. It's this angle across from the 90 degree, and it is the longest. Now the converse of Pythagorean's theorem is just if I can do a squared plus b squared equals c squared, it means it's a right triangle. If that works, it is a right triangle. So even if I didn't tell you it's a right one and you plug those in and it works, then I can say it is. Now, if I plug in a squared plus b squared and whatever I get is less than c squared, that means it is an acute triangle, meaning that angle is less than 90 degrees, that kind of little one there. And if I do a squared plus b squared is greater than c squared, that means it is obtuse. So this just would tell us, like, okay, so here's our right triangle. This one would look more kind of like that. Oops. Pretend that was not a 90 degree angle. And then we'd have our obtuse. C is always the longest side too, so that's how we know what we plug in. Isosceles right triangle, this is what we got from the last time, that if I have my right triangle, those are equal, which makes those 90. If this is x, this is x, this is x square root of 2. We also have a special one, which is a little harder to prove with the information we currently have, but it is a 30, 60, 90 triangle. So there are some relationships here. So here's our 90 degree, this is our 30, and this would be 60. The side across from the 30, or the smallest side, is always x. The side across from the 60, or the middle side, the medium side, with the longest leg, is x square root of 3. And the hypotenuse then is always 2x. So an example problem, I might tell you that the hypotenuse is 10. Then you could tell me that this is 5, because 2 times 5 is 10, so x is 5. And then this side would be 5 square root of 3. So you don't actually have to go through and use Pythagorean's theorem, because this is the pattern that exists every time on a 30, 60, 90. Same thing here. You wouldn't have to go through and use Pythagorean's theorem, because that always exists on a 45, 45, 90. Okay, our last one was area of a regular polygon. So let's say I asked you to find the area. Well, that's a really crummy drawing, but of this hexagon, and I said from here to here it's 3 inches, and from here to here it's 4 inches. So kind of the longer way to do it is to say, oh, look I have a triangle, and that is 3, that would be 1/2 of 3 times 4, 1/2 base times height, And then I would take that times 6 because I would have 6 of those triangles. I can find the area that way. Not too bad. Some people would prefer to do this, and that's just fine too. The other option that you have is if we call this the apothem, which is really just from the center. It's going to kind of the height of half of it in a way. It's a line straight from the center. It has to make that 90-degree angle with the length of the base. You can find the area by taking 1/2 of whatever that apothem is times the perimeter. That would work as well. So sometimes they'll tell you like the perimeter and you have to say the apothem. It's really up to you which one you prefer. I guess for me, I hate memorizing something, and this makes more sense pretty quick, but you could do this as well. All right, good luck.